Hello everyone, welcome to the channel Mathematics Pathshala. Today we will solve a problem of integral equation which is taken from CSIR UGC 8 December 2023 from part B and the question ID is 704047. Here it is said to find the value of lambda for this given integral equation. This has a non-zero solution. So here you may have already noticed that this given integral equation is of Fredholm type since here both the limits are constants. Now to solve this kind of integral equation, see how can we approach. So here it is given yx is equals to lambda into integration over 0 to 1 x square e to the power x plus t yt dt. So we can write it as lambda x square e to the power x integration over 0 to 1 e to the power t yt dt, as here the integration is with respect to t. Now if we consider this integral portion as c, then c will be integration over 0 to 1 to the power t yt dt. Then yx will become lambda x square e to the power x into c, and from these we can write it as yt is equals to lambda t square into e to the power t into c. Now if we consider these as 1 and this is as 2. Now let's see, using 2 in 1. Here if we put yt, this yt in 1, then what we get? We get c is equals to integration over 0 to 1 e to the power t into lambda t square e to the power t into c dt using 2 in 1. So from here what we get by calculating, here we get lambda c integration over 0 to 1, here t square e to the power 2t dt. Now see, here we have to integrate it by the bypass rule of integration. So here if we apply bypass rule, what we get? We get t square into integration over e to the power 2t dt, and here the limit is 0 to 1, minus integration over 0 to 1 ddt of t square, that is 2t, into integration over e to the power 2t, that will be e to the power 2t by 2 dt. So here it will be c is equals to lambda c into, here if we integrate this, what we get? We get t square into e to the power 2t by 2, and here the limit is 0 to 1, minus here 2 and 2 will be crossed off, so we get integration over 0 to 1 t into e to the power 2t dt. Now in this portion c is equals to lambda c into, here we can put the limits. So putting the limits, we get e square by 2 minus 0, and again we have to integrate this by the bypass rule. Then what we get from here, taking this outside, we get t into integration over e to the power 2t dt, limit is 0 to 1, minus integration over ddt of t, that is 1, and minus ddt of t, that is 1, and here integration over e to the power 2t, that is e to the power 2t by 2 dt. Here also limit is 0 to 1. So we get c is equals to lambda c into, here it will be square by 2 minus, what we get here, we get t into integrating e to the power 2t by 2, and the limit 0 to 1 minus, here half of integration over e to the power 2t dt, that is e to the power 2t by 2, and here the limit is also 0 to 1. So in the next step we can apply the upper and lower limit in this portion. So it is as it is equals to lambda c into square by 2 minus, here if we put the limits we get here square by 2 minus 0. Multiplying minus and minus, it will be plus, and putting the limits, here we get square by 4 minus 1 by 4. So this two term will be crossed off, and finally we get c is equals to lambda c into square minus 1 by 4. If we take this in the left side, but we get c into 1 minus lambda into square minus 1 by 4. This will be 0. Now in this problem we have to solve the non-zero solution for this given integral equation. So here if c is equals to 0 we get the trivial solution. So c must be non-zero, and c, if c is non-zero, then 1 minus lambda into square minus 1 by 4 is must be 0. So from here what we get lambda into square minus 1 by 4 is equals to 1, that is lambda is equals to 4 by square minus 1. So we get from here lambda is equals to 4 by square minus 1 for the non-zero solution of this integral equation. So option 3 is our correct answer. Lambda is equals to 4 by square minus 1. Thank you everyone for watching the video.